So it's actually time for our first speaker. We're a little ahead of the program, but that's totally all right. We have Martin Westblom here today from NVIDIA, and Martin is Enterprise Manager is his title. And I'm very pleased to have Martin here because NVIDIA is the largest sort of AI company in the world, and was actually the largest company in the world overall, bigger than Apple, if you look at the stock market price. And they are producing like something like, I don't know how many percentages, but a large percent of all the AI chips that are actually powering this revolution. So this is one of the most important companies around when it comes to AI. And I know they have some pretty revolutionary stuff going on that are intimately tied to the longevity revolution. So with that, I'm very happy to invite Martin up on stage. Martin, let's do this.
Thank you. Let's see how this works. Thank you for having me. So, Alliance Manager for Nordics and Benelux. I'm taking care of the ecosystem we have at NVIDIA. So first of all, how many of you guys know who NVIDIA is? Raise your hand. Oh, shit. How many of you did know who NVIDIA was 4 years ago? Okay. Okay. Expecting to be a little bit lower, but 4 years ago, we were a gaming company, most of it. 55% of our revenue 4 years ago was gaming. Today, that's 6%. That's only 6% that we do in gaming. So we do transform ourselves within NVIDIA, and I'm going to talk you through who we are, what we do, and why it matters in this forum, what we do within AI. So Santa Clara-based company, US-based, founded in 1993, so we are quite young. We're one of the few companies who still has our CEO left, the founder, Jensen Huang. He's still running the company, and he's running it quite hard, to say. So he's an amazing guy. 30,000 people in the US, and we were, as Linus said, the biggest company in the world for 4 days. So we're going up and down, but what I would like to say with that, some people really think that AI is on hype. I used to take our market cap as an example. It's not a hype. It's happening now as we speak. And you see it all. It's happening everywhere. It's impacting your life, the society, how we act, how we communicate with each other. It's an amazing thing going on, and we play a small part of it. Yes, Linus said, but there's so many people doing AI. Just look in this room. So with that said, please, you're welcome to join. If you are in Santa Clara, San Francisco, Bay Area, just come by. It's quite easy to hang out with us, to just join and see what we do. So, NVIDIA, the gaming company. So we took this thing. Have you heard about a GPU, a graphical card? So we were thinking about, a couple of years ago, we thought that this thing is actually good at compute, to process stuff very, very fast. And that is what we're doing. So from a company perspective, we sell stuff. We sell chips. You know, all this discussion around computing and so on. We're selling networking, we're selling hardware. Such a hardware company from that perspective. But that's not that creates the need as such for NVIDIA. So I'm going to explain this very fast. We start from the top. So we create the toolkits, the frameworks for doing AI. That is what we do. We don't, as a company at NVIDIA, do AI. And that's a big misunderstanding of us as a company. Because you guys in this room do the AI stuff. We just hand you the tools. That's our way. If we work us on the top here, so we're doing large language models, if you heard about that thing. We're working within automotive, for example. We're working in retail, within healthcare. We're going to speak about healthcare today. We're working in encryption, fraud detection, defense. We are pretty much everywhere. But in the bottom line, you're using these kind of GPUs to compute it, to train it, to understand it. So this is what we do. 95% of our revenue is these things down there, because we give our software away. You can just download pretty much every part of our software stack just for free, from GitHub, from Hugging Face, from our own repositories on the web, and that's how we go to market. Our second biggest vertical at NVIDIA is healthcare. We are huge within healthcare, and I'm going to talk you through this, how it works. In the middle, we have something called CUDA, and I know this is not the forum to explain what CUDA is doing from a technical perspective. I just want you to bring this with you. Every people that using this kind of technology in the bottom line uses CUDA, because that's our API, that's our instruction set to talk with all these strange software stacks on top. So think of this when I'm moving forward in the presentation, this strange CUDA thing, frameworks, and toolkits. That's how we approach a market, and that's what the market sees us from a market cap as an important player in this AI world coming up. So everyone following me so far? It's okay? We're good to go? Cool, cool. All right, thank you. So, back to gaming. So we have this thing, Minecraft, for example. I also explain how this gaming world, where we did start a couple of years ago, 2004, I think, we were launching our first GPU for gaming. Anyone played Sega Rally and these kind of things? Minecraft, what we are doing in the back is, for example, the physics engine in Minecraft. If you put something on fire in Minecraft, if you throw something up in the air, for example, or if you're trying to build something in wood and density, we are the company that is building the engines for it, the physics engine, to simulate as far as possible to the reality. That's our strength. So this is what we did in the gaming, such as Counter-Strike or this Minecraft or SimCity, all these things that build our company as NVIDIAns. And how we did it was, for example, to calculate pixels. If you think of this thing driving around, the immense compute you need to have in your PC to find this pixel in the right spot in nanoseconds to showcase for you a graphical experience. That we did on something called GPU. And Jens and Ang and the team, a couple of years ago, 15, 20 years ago, then discovered if we can do this for a pixel, millions of pixels in nanoseconds to be updated to give this experience, you should be able to do this on compute. To build data models, aging models, and calculate the next steps within. It's called parallelism, and that was building our company as such. So if you, any questions, just feel free. Any questions so far? Do you following me? Keep it open. All right? So this is actually a quite funny thing because we call it ray tracing. That's funded in Sweden. There's a bunch of guys sitting in Lund doing this thing for us, for the world. Super nerdy technique. You can't even speak to these guys. It's so funny. So they're doing this stuff, and it's used all over the place. So ray tracing. How do we use this now? I'm just going to give one example that I think comes close to you. If you sit in a Volvo car, in a Polestar car, in a Mercedes-Benz C-Class and B-Class, now the new models from Tesla last year, we're using this kind of technology in the cars. So if you let your hands go in a Volvo Polestar, you actually have NVIDIA software doing that in your car, at the edge. You're having NVIDIA GPUs in the car processing this data. We're doing the stuff like having the car to brake. We are identifying if the car is running on, if it's raining, if it's fog. If you see the line when you let your hands go, it's cameras using radar and lidar to see where the lines are and keep it safe for you. And this is for technologies like ray tracing. Instead of light, we're thinking of this radar technology, but we're using the same thing. and we're having the same CUDA core processors in the car to understand what's going on. So that's what we do. We're doing the same. If you see a Scania, if there's anyone from Scania here, you Scania guys seems to be everywhere. Okay, no, you're not. Okay, so if you see a black Scania truck driving between Jönköping and Södertälje and Oskarshamn, back and forwards, you can see on that truck that there is an NVIDIA logos. They have 5 of these. So they're driving back and forth and collecting data to the data centers, 80 gigs per drive. And we are training an AI model to understand how a truck could behave, to get self-driving. You know, Enride, these guys are doing this. And it's immense compute power needed to understand and train this stuff. So this is what we do within, for example, automotive. This is one piece of it. So if you look at the Sensart guys in Gothenburg, it's 600 software developers pulling out data from the streets, from the roads, and train that data and process it and put it as a software piece in the car. So that's our way forward, and that's what we do from our side. So I want to speak through what is generative AI. Have anyone heard about this generative thing? No? 2 years ago, something happened. ChatGPT came out, yada, yada. Everyone knows that thing. And it pushes the generative AI. I want to explain the difference, how we see it, how I see it personally from an AI perspective. We had, a couple years ago, you could take a picture of a cat, and you can ask the computer, the machine, what is this? I mean, it's a high probability that this thing is a cat. And we were training these models to understand it's a cat. We just take the same picture and put it upside down. So if I ask Linus, is this cat upside down a cat? Yeah, probably. A machine have no clue. We need to ping it with metadata and say, this very same picture upside down, it's a cat. You put a spot of yellow in the middle, that's a new picture for the machine again. And we do this iteration many, many times over again. Imagine when you do this on 4 terabyte pictures from an X-ray. So this is what we do to understand, for example, in Gothenburg University, together with VGR, how can we identify breast cancer anomaliteter, please? Anomalies. We take millions of pictures of breast cancer, huge pictures, and train it over and over again. Do we find spots that shouldn't be here? And we do it on parallelism, the models, the frameworks. We give it to VGR, for example, in this case, to use our tools. But we don't do the AI stuff. You, as a customers, are doing that. And they're using this technology of hardware to train it. So if you take generative AI, once again, you send a request, is this a house? The difference now is we're asking the models, build me this house. I want this house orange. I want this house to have a kitchen. It should have a sofa. I want this house to be old. Should be in wood. And the models is building it. And understanding how intense that is on the compute power, that's what we're seeing here with the big hyperscalers building big superclusters and data centers and so on. But this is also going to drop down to you guys. So generative AI is a huge thing, and we are all impacted by it, and we just seen the scratch, just seen the start of it. And that also explains the hype around the NVIDIA market cap, because the market, yes, there's stuff happening, but it's not yet started. It's coming very, very aggressive. Any question about generative AI? I see we do have some time. What? No, nothing. Crystal clear. Yes, we do. Holy crap, we have a lot. I just want to give some, what do you call it, reclam, commercial. So we actually have our own language model in Sweden. And this is, when we talk about language models, what we do in LLM And just bear with me, because I'm going for examples within your area very, very soon. What you want to do is to understand, or when you ask a model a question, what is the possibility that Linus will take a beer this night? Based on training on that data, the model will probably answer yes, or maybe no. And this is what we do with Brezelius, the Swedish data center. It's a big cluster at Linköping University where we train the Swedish GPT-3 models. And just to show the difference between the Swedish model, GPT-3 and GPT-4, it's kind of huge. 1.4 was the GPT-3 model scoring on the high school test. 1.9 it did on the new GPT-4, because it's so many more parameters that it's trained on. The only thing that is hard to describe is the thing there. We need to describe for the test what we actually seeing, and that's very difficult. So this is a Swedish model that is available through AO Sweden. You just download it for free. It's 20 gigabytes, and use it on your own purpose. So that's a pretty cool thing. In healthcare, this is our second biggest vertical. So just do we just take one step back. We were doing frameworks, right? We're doing toolkits. We're giving you guys the toolkits to do stuff. And then you're using it and to train your own things. So we have a lot of things going on within healthcare. Robotics is when you're doing surgical from distance, and you have people, doctors doing many surgeons in a more effective way. You have instruments. That's where we're doing this training of big, large X-rays, for example. You have imaging, where we have models, where we have frameworks to understand the anomalies, for example, and so on and so on and so on. We have a lot of stuff going on. Genomics parabricks, that's probably the one that you might be looking into in this room. So this is, once again, our approach to the go-to-market, what we do at NVIDIA. We give this away for free. You can just download it and try it on your own computer at home, but it will take immense of time to try to train something. So you create the data and you train it. That's where we come in at NVIDIA side. So from a healthcare perspective, why do we think from NVIDIA side that this is important? What are we actually doing? So if you take protein folding, for example, if you want to find a cure for Alzheimer's, if you want to try to find a cure for Ebola virus or anything like that, it's so much more effective to do it at scale, computing that need. And I think you all understand that in this room, what this can bring. So, for example, Danish Technical University, they're trying to find a cure for Alzheimer's, for example. And then they're using our kind of technology as trained models and using it on data from Stanford, from Camford, and the Copenhagen region. And the point here is that if you're going to do it, it's so many years it's going to take to do it manually. You can't even describe it. You need to compute this. You need accelerated computing. You need these chip designers who we represent, and there's many more of us doing that. It's not only NVIDIA. And this is where NVIDIA comes into the picture. If you take one example, for example, you saw this, right? Yes? Yes, yes. The interesting part here is that these two guys to the right, these are IT guys, right? You know that. This is Google guys. This is no doctors or scientists as such. They created one of these frameworks, one of these toolkits I'm talking about, one of these things that talks this thing in the middle I called CUDA. They created a software that talks to our GPUs to train stuff. So these are Google DeepMind guys. They created something called AlphaFold, and I think you guys are going to talk about it later on. And this is where we train protein, where we're trying in a large language model sense, try to understand what is the next sequence, what's the possibility of if we're mixing these molecules in this way, that we can cure Ebola, or that we can cure Alzheimer's in this kind of sequence. You're following me why we're using these language models for this purpose. AlphaFold is immensely effective in doing it, but they need GPUs, they need compute power, they need these big, big data centers to be able to do it. So, for example, one of these big data centers is what we do in Denmark region. And today, our CIO, Jensen Oang, is in Copenhagen to do the release. Do you say party? Yes, it's some kind of party, probably, for Novo Nordics. So where we come in strong as NVIDIA is not actually the Novo Nordics. We're working with the Novo Nordics Foundation. And what the Novo Nordics Foundation wants to do is to build a platform, predominantly in the start, using, for example, AlphaFold 2 in this sense. And the mission, the goal for these guys is to find a cure for Alzheimer's. So it's a big, big investment, and we want to see this coming to Sweden as well, because all of you guys know in this room, we are lacking behind when it comes to the AI capability. We don't do our job here, and you've maybe seen that in the news and so on. I don't know what's wrong with Swedish people. We are kind of slow, but we got help, right? So we're starting to come back on this. But there is a lot of people talking about how do Sweden catch up in this sense. So the GIFION is a big supercomputer founded by the GIFION Foundation. And the GIFION Foundation's aim is to get the Danish AI nation as a capability to be able to train these big, big models. And what happened, they put stuff like this in. I had to do it. It's a hardware piece. It's a thing. This is a GPU. This is a chip that you put in a data center. This is what GIFION buys from NVIDIA. But they're using the software stack. They're using the AlphaFold to train models, to extend the life for people, to find a cure, to understand how do we approach new diseases. If something new comes from somewhere, they can put this in a laboratory, in a computer, and just train it, iterate it, understand it, twist it around, figure out how could we break this chain? How can we make this thing not killing us all? This is what we do. This is what NVIDIA is doing. This is the chip thing that we are doing, that we're seeing. And the performance thing is insane. Just the last iteration, we talked about it, the Blackwell thing, as we call it. We used to have awesome acronyms for everything we do. So it's 4 times faster. It also means it consumes 4 times more energy. So it's kind of brutal to the environment. But we do claim that we are nice to the environment because you need so much else if you don't have this thing. It also can be very tricky, this AI thing. And this is actually my last piece, because you said 50 minutes. So we have a lot of time for questions now, right? What happened if you train the data wrong? And this is to all you guys in the room, because this is extremely important to bear with me here. If you train a model on wrong data, now, that's not a good thing to do, because this could be the outcome. Imagine that you have this 1 billion Danish crown investment for GPUs in data center in Denmark to actually find the AI model using the toolkit from AlphaFold, the framework for AlphaFold. And yes, here we have. We can cure Alzheimer's. We're good to go. Everyone is happy. It's lovely. You could also ask that model, please kill humanity in 3 months. Make it as painful as possible, and we want that model now. Train it for us. The thing at GIFION, the data center, the cluster, will do its utmost to kill you guys in 3 months. That model could be very, very dangerous. So this is also an ask in the room. Think about what kind of data you have. Because data is extremely important. That's what we train stuff on. Think of who is using that data. It's also kind of important. Because we are living in a bubble at the moment. Generative AI is so nice. But we at NVIDIA, we also see that this is some dangerous stuff, depending on who is using it. I think you are all with me on this one. So I do have time for questions. Yes, so that's kind of, yeah, me.
Thank you, Martin. All right, any questions in the room? Please go ahead.
Can you tell us more about the two biology-related models that you showed on the slide?
The two?
Yeah, one was genomics, and the other one was bio, I think it was called.
BioNemo, we have a lot of models. So if you look at the vertical F, what we call it Clara Bricks, that's the name. We love cool names. We have hundreds, 120 different models within the vertical of genomics or BioNemo, that's for protein folding as such. It's actually competing to the Nobel Prize guys, so yeah. So it's not very successful. So we're trying to compete with DeepMind. But anyway, all these kind of models, they are written and understandable to our GPUs, and that's the case here. So AlphaFold 2 is a tremendous success for us. Even if we are not the guys doing it, they still train this stuff on our thing. If you look at the ChatGPT, so NVIDIA is a little bit secret. The ChatGPT, when it was launched, no one told anyone that it was NVIDIA frameworks that trained it. OpenAI have been using NVIDIA since 2014. The whole model was trained on 150,000 GPUs in the Azure cloud. We don't say that. We like to be the guys lurking around in the back. It has always been, until today, I guess. So, but yes, please reach out to me. We have a bunch of people here in Stockholm, predominantly working with this kind of BioNemo or Parabricks. Yes, we do. Yes, more. Shoot. We are. Yes, what responsibility does NVIDIA have in securing that the models are used correctly, or in our stage, it's trained correctly? So, when Meta is launching the Llama 3 models, 3 months later, always from NVIDIA, we're launching the Llama 3 Nemo interaction. So Nemo from our side, once again, cool acronyms, we're using guardrailing. So we're guardrailing all the stuff. We're trying to understand what is this thing trained on. Do we have is it trained on data from any racist stuff? What do we find this data from? We don't use ChatGPT's model because that model is so extremely fishy. It trained on all internet data. It's not controllable. You don't know where the data comes from. If you ask that model a trick question, that thing will answer very, very strange back to you. So you need to be careful. So when we published the Llama 3.1 iteration, 70 billion parameters on Hugging Face for free, download it. Then we have a stamp. This is guardrailed, understand from NVIDIA's side. Use it. Is it 100% safe? No, will never be. So that's a tricky one. But we're trying to guardrail. And what we do, for example, for big companies like anyone, like Ericsson. So, okay, guys at NVIDIA, we would love to use the Llama 3 model for our customer experience. Maybe anyone from Ericsson here? No, okay. What we can do then is retrain it. We call it fine-tuning, and that's one of the biggest steps within NVIDIA's workloads. So we take the model and fine-tune it on Ericsson's data. We want the model to understand what Ericsson is doing. We want the model to be responsible for the answers it gives to Ericsson's customers. And this comes all around. Mm-hmm. But it's a very, very tricky question. Yes, there's no clear answer.
All right. With that, we thank Martin.
All right. Thank you.